functions or exponential equations and inequalities is exactly the same. So solving something like this is when we have an x as an exponent. So we're going to have like a y equals something to the x power. Okay, when you end up with something like this, that's what we're going to solve and how we're going to work it out. Okay, so exponential function is an equation where the variable is an exponent. You see an x or y or a or whatever as an exponent. What we're going to do. Okay, if we let the base be whatever our, like in this case a 3, whatever the base is, as long as it is greater than 0 and not 1, we can say if we have two things that are equal, where the bases are the same, I can say that the exponents have to be the same. In other words, if I had 3 squared equals 3x, well, what does x have to be? 2. X has to be 2. So if the bases are the same, the exponents have to be the same. Does this make sense in what they're saying? Okay. So it says, for example, if 3 to the x equals 2 to the 5th, then x equals 5. If x equals 5, then if 3 is to the x power, then I can write it as 3 to the 5. Okay? And I will note down here, this only works when the bases are the same. Only. You have to have the bases the same, otherwise you can do that.
Bases are like 1, right?
The bases are like these 3's. Whatever that is to the power. No. Okay, so if we're looking at this first equation, are my bases the same? No. Okay, it is possible. We can't do this. We can't, because I can write 8 as 2 to the something power. 2 to the what power gives me 8? 2 to the 3rd power. Okay, so this is 8. Then I'm going to put this 3. This 3 is the one that goes on the outside. So we still have 2 to the x. Okay, have I lost anybody? You understand what I'm doing? Why do I have 2 3's up there? Make sense? Yeah. Okay, so then, what happens when I have a power to a power? Multiply. So it's 3 times 3? So I have 2 to the 9 equals 2 to the x. So x is 9. That is the basis for today. If you can do this, you can do today's stuff. That's all we're doing. Okay? Alright, let's look at B. Bases are not the same. How can I rewrite it so the bases are the same? Multiply it by 3. What's the world?
Only one time.
3 squared equals 9. There we go. Because 3 squared is 9. So we're going to put that on the outside here. Okay, then what? Yep. Notice that we have to distribute this 2. We have to multiply it through everything here. So we're going to have 4x minus 2. You guys say that 2 times everything. Alright? So now our bases are the same. We could say 4x minus 2 is 6x, and then just solve for like a regular equation. So subtract the 4 over.
You get 6x.
Because that's what it says up here.
Why is it 3 6x?
What?
What happens to the 3?
The 3 is gone. It's like over here where x is 9. I'm just pulling the exponents out.
Oh, okay.
Oh, so you make the bases the same and then you pull. They do this solution.
Yep. Once the base is the same, we can pull out the exponents and make them equal to each other. Yep. All right. Any questions so far? Okay. Let's look at C. What are we gonna do?
Cool.
You take and make 64 and
4 to the 3rd.
4 to the 3rd. Okay, bases are the same. Now what? Good. The exponents equal to each other. Okay, so then add the 1 over and this.
This is really easy.
Told you guys know.
Wait, is it a work here?
No.
Yeah, it's easy.
All right. Do you want to do D or do you want to move on?
Yeah.
I promise it's not going to get much.
That's not talking about.
All right, look at example 2. It says,
Example B.
look at it too. I want to. Okay, so example 2 says, first experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that can be used to model the number of bacteria after X amount of hours if the number of bacteria changes at the same rate. I'm going to give you a new little formula thing to plug in.
What a coincidence. We're learning about bacteria and science.
Are you really?
Yeah.
Okay, so our new formula is y equals a times b to the x. Okay, just like we were talking about exponential decay and growth yesterday, what did a stand for?
Like I think we were.
Yeah, where we started, right? The initial, right? So in this case, what did she start with? So that's what our A is. Okay, so where we start.
23,000 is the one.
23,000 is the y. Why?
Because it's what you want.
Yep. Okay. So that's the square time.
That's how that comes up.
All right. B is how much it's changing. We don't know how much it's changing. But, like yesterday, it was an exponent of the t. X is still going to be like our time. So what's our time?
4.
Okay, so after 4 hours, if it changes by b amount, we're going to end up with 23,000. So now we have to solve for b. Okay, I would first get rid of this guy. How do I get rid of the 7,500s?
Divide.
Multiply. Yep. And then what? I don't know what this is off the top of my head. Let's see.
It's 3.06666. 3.066. It's repeating.
Okay, keep all those decimal places that I typed in there. Don't clear it. Don't clear it. We'll put it back in there.
It's what's
Why not?
It's 3 to 15.
Okay, 3 to 15. Okay, so then how are we going to get b by itself? How do we get rid of that 4? Take the 4th root. So you're going to take the 4th root of everything. You put this.
Second, 4.
Yeah, I think so. And then push forward.
How do I put all that on?
Yes. Okay, do we have control of the calculator?
How do I do that? Is it this thing? It's repeating decimal that never ends.
It's tiny better. It's the same exact thing.
You get one for each other.
Yeah, well, mine's flat. Great.
Somebody would not to raise this. Gosh.
You're the racist. You're the one that doesn't like black things. That's what I am not racist.
All right, so we end up with b is about what?
1.32.
Okay, let's go. Okay, let's go to 3 decimal places. So 1.3. All right, so that's what we're going to use. So we're going to put it back into our equation because they want to know how we can model the number of bacteria after X amount of hours. So they just want us to write an equation. So we're going to put X and Y back in. We're not going to put numbers for X and Y, they're just going to be X and Y. A stays the same, and our new B goes in there to the X power, and that will be right.
Rocket scientists just threw stuff.
We're not going to be able to figure it out if you don't know how to do the formula.
Let's
They're not going to it from sophomore kids.
Well, every scientist is going to start somewhere, and they all started as sophomore kids, too. All right, let's do the next one. How many bacteria cells can be expected in the sample after 12 hours? What are you going to do? It's L into your equation. Where does the 12 go?
Yeah.
4, that makes more sense.
Okay, and then think the order of operations. What should you do first? Exponents, then multiply. Well, we'll round to the nearest whole number. Okay.
Now I'm really confused how to do this.
And you're really confused.
Shut up, Lindsay. Wow.
Nice.
And then
Oh, that's a funny ball.
Put in your base.
I'm not gonna
Like
like
this.
corn.
And you're gonna go this, and then shift. Because it's
I'm
not.
not like corn.
So you're just gonna go this.
Grass.
And then take it out.
Okay.
Give me a
So,
different
it's never said. Right.
There's no corn in that grass.
I'm really confused.
Anybody still have questions for them?
Yes, I am. I keep thinking I got this under like 3 points. Okay, so yeah.
Who would name a team corn?
Oh, never mind.
Times.
Never mind.
No, it's something.
There you go. I
All right, next page. Okay, this is exactly like what we just did. Do you want to go through another one?
No.
All right, compound interest. Compound interest, we have another little formula here. So in order to figure it out, A is just going to be the amount of your kind of the bank account after T number of years. Notice T is up here in your exponent again. P is the principal amount invested, meaning how much did you put in the account originally? It's like our A earlier. R is the annual interest rate, and then N is the number of compounding periods each year. Meaning, if it's semi-annually, that makes 2 times a year. If it's quarterly, that means it's 4 times a year. That kind of thing. How many times a year? Okay. So, example A says an investment account pays 4.2% annual interest compounded monthly. If 2,500 is invested in this account, what will be the balance after 15 years?
We might actually use that.
Okay, so we're looking for how much is in the account. So put in A. What's our P? I know. Okay, so we're investing 2,500 originally. Okay, and then we have 1 plus, what is R?
4.0.
Point, yep.
0.14. Just guessing that because it's
Over what's in.
12
Why is it 12? There's no 12 in our code.
monthly and there's 12 months a year.
Good, yes, compounded monthly, so 12 times.
There's 12 times 15.
Right, because N is still 12 times T, and they want it after 15 years.
Can you imagine it's so fun? I feel like I think it's 12 times 15.
Because it's N times T, so N is how many times it's compounded, that's 12. T is however many years we want it.
Is it usually compounded monthly?
Sometimes, or sometimes it's quarterly, 4 times a year.
Then we go forward.
Then you do 4. Yep. All right. So doing order of operations, I would simplify stuff in the parentheses. That should be about this. And then 12 times 15 is 180. So take that 180 times
0.
none.
That's 0.
Typing it in your calculator.
Yes. So you made no money.
Something is not right. Because it should not be 0.
Mistake.
Did you do
You're
12?
weird.
Yeah. Did you do 0, 0, 2, 7, 12, plus 1? I got 4,600.
Oh, I forgot. That's what I had.
Same here. You amazing person.
Yeah.
Four, six, eight,
Oh, yeah,
eight.
yeah.
6, 4, 6, 6.
Yeah. love those things.
But I didn't take a lot of time.
Don't lie. You know, okay, it's not a foul though.
Well, then that's not a
It's
good.
in dollars.
$46, 188.87.
It's kind of low. Go.
No.
I just got 4,688.
Yeah.
22.87.
Yeah.
I think I was to this.
So she qualified as towards her.
No, you're right.
She's like, I love that.
Okay, enough, guys, quick, or I'm going to give you some more assignment problems. I'm getting tired.
Wait.
So it should be
How'd you get-
4,030. I missed the decimals.
Don't step around the up or down.
They're around down, like someone.
Points.
It's be the same
Oh.
thing.
It's
It's the same thing. Yep.
Do you mind if we do, or do you?
There's someone who's asking around.
I think we're good. Do you guys understand how we do this? All right. Last thing on the last page. Exponential inequalities are exactly like what we did on the front side. However, in this case, instead of equal sign, they just put a less than or greater than or equal to in there or something like that. But it's exactly the same idea, exactly the same kind of steps. Okay? So in other words, if a to the x is greater than or equal to 2 to the 6th, then we're going to say x is not equal to, but x is greater than or equal to 6. And again, we can plug it back in. So if x is greater than 6, then 2 to the x is going to be greater than 2 to the 6th.
What's a greater?
Because this is just a greater than, it's not a greater than or equal to. And note, this is with exponential functions, and it only works again if the bases are the same. You can only pull out those exponents if they are the same bases. Yeah.
You're not on the second on Thursday.
Depends on how your behavior is.
So we're having a second.
All right, let's do 8. So, how can I make it so the bases are the same?
To the fourth and to the third.
Right, we have to change both of them. Now, there's no way that I can get an 8 to the something power to get 16. Yes, I know that 8 times 2 is 16, but 8 to no power will get me.
You have common, common.
Yeah. So, in this case, okay, well, 4 to the what power gets us 8?
2.
2. Okay. 2 to the what power gets us 8?
Third.
2 to the third, and 2 to the what power gets us 16? 4. So we have 2x minus 3. Okay, again, remember we have to distribute that 4. Now our bases are the same, so we can pull them out, our exponents. In this case, remember that we have our less than instead of equals, and just solve it like normal. So add that to the over.
That's basically just the same side to back.
Yep, I told you this is exactly the same steps.
Okay.
Alright, part B looks a little bit scary just because there's a fraction in there, and I promise it's not.
That's a negative exponent.
Right, we can make it into a negative exponent because this is the same thing as saying 243 to the negative 1 power, right? So now we just need to figure out, okay, well, since this is a base of 3, we can't really go any lower than that. So we need to figure out 3 to the what power? Is it to the 5th? I don't remember. I think you're right.
Yeah.
So we're going to go to the negative 5th because it's a fraction, it's in the bottom. And then, again, base is the same, so you can pull the exponents, make them equal to each other, and solve. It's not bad. Remember,
I think circles. Circles.
all right, do you want to do the last one? Or you guys get it?